Look closely at this busy carpentry workshop. Every day, builders cut expensive materials like mahogany timber to exact sizes. Once a piece is cut too short, it cannot be stretched back out. The accuracy of that cut depends entirely on the line drawn before the saw even touches the wood. If you mark your cut with a blunt tool, like chalk, the line itself might be 3 millimeters wide. The person cutting is left guessing where the true center of that mark actually is. On the right, a sharp pencil line provides a single, precise path. In technology and design, guessing always leads to wasted material and lost money. Precise measuring and marking are the strict requirements for building any successful project. When you transition into the workshop, your standard plastic school ruler is no longer accurate enough. We replace it with the rigid workshop steel rule. Take a close look at the starting edges. A school ruler has a small blank gap before the zero mark to account for wear and tear in your bag. The steel rule starts its zero mark directly at the physical absolute edge of the metal. That absolute edge allows you to hook the rule directly over the physical corner of a workpiece. You lock your zero exactly to the end of the material. By anchoring to a true physical zero, you establish a perfect baseline. From this point on, every measurement you take in the workshop must be recorded strictly in millimeters. Once measured, you must mark it. To scratch a line perfectly parallel to the edge, we use the marking gauge. It operates using 4 parts: the sliding stock, wooden stem, sharp metal spur, and the thumb screw to lock the measurement in place. The most common mistake is pressing down too hard. Wood has natural fibers and grain. Heavy pressure traps the spur in that grain, pulling your line entirely off course. Instead, set the gauge and drag it lightly across the surface several times to slowly deepen the scratch. When you need to cut across the wood rather than parallel to it, a tri-square gives you a flawless 90-degree guide for your pencil. Wood requires marking techniques that actively compensate for its texture. When we switch materials, the physics change entirely. Mild steel has a smooth, hard surface. A pencil's graphite fails to adhere and rubs away instantly. To mark metal, we use a scriber. Its hardened steel point physically alters the surface, scratching a permanent, bright silver groove directly into the metal. Taking that same scriber to acrylic plastic will destroy it. The heavy pressure forces the brittle plastic to crack. For brittle materials, remove physical pressure. A fine-tip permanent marker leaves a highly visible ink line exactly where needed, without stressing the material. Your choice of marking tool always depends on the surface physics of your material: hard scratches for resilient metal and zero-pressure ink for brittle plastics. This cross-section diagram shows a round PVC water pipe. If you try to measure the exact outside thickness of this pipe using a flat, straight rule, the flat edge cannot align properly with the curved geometry, leaving a visual gap. To capture external curves, we use outside calipers. Their inward-pointing legs wrap perfectly around the pipe. To measure the internal hole, switch to inside calipers, expanding outward to touch the inner walls. Hold that gap against a steel rule to read the measurement. Calipers act as physical memory. They extract the exact distance from impossible 3-dimensional curves and translate it onto a flat rule that you can read. Let's test your logic. Match the 3 marking tools on the bottom to the correct materials on top. Here's the solution. The pencil and marking gauge handle wood grain. The scriber tackles hard steel, and the permanent marker safely marks brittle plastic. Accuracy relies entirely on the physical condition of these tools. Hidden physical damage directly translates to thick, crooked lines and ruined materials. The steel rule must be kept dry to prevent rust. Most importantly, it must be isolated from heavy workshop tools like hammers. A single dent on its straight edge destroys the absolute zero baseline we established earlier. Your marking tools require equal care. You must regularly use a sharpening stone to keep your scribers and marking gauge spurs needle sharp, and always click the cap back onto your permanent marker immediately to stop the ink from drying out. Consistent maintenance is the only way to guarantee your tools remain reliable, from the first measurement to the final cut. Here is your complete precision toolkit. Take a screenshot of this summary chart to use as a quick reference for matching materials to correct tools. Every masterpiece you build begins with a perfectly drawn line. Treat your tools with respect, match them properly to your material, and remember the workshop rule: measure twice, cut once.